So in this next question, we have a mixture of this NMR spectroscopy and X-ray crystallography. So X-ray crystallography has been taken out from the 2016 syllabus onwards, but NMR has remained since with the addition of carbon-13 NMR. So we're just going to jump straight to NMR spectroscopy. So this first question is relevant. This second question is about X-ray, so that is not relevant. So how can I detect hydrogen atoms in molecules? So hydrogen atoms, specifically the one that contain protons, hydrogen atoms containing the protons. Essentially, we're talking about this hydrogen 1 atom. They have magnetically active nuclei, and it is this thing that are used in these magnetic spins, where we don't talk too much about this spin up and spin down, but we're talking about nuclear spin. So it has nuclear spin, and it is this nuclear spin that allow it to couple, allowing coupling to neighboring protons. And when you couple to neighboring protons, you're going to see splitting patterns that would enable you to map up the structure depending on what splitting you see there. So I don't think this is quite relevant for the new syllabus. It's basically about the operating principles, and the idea that students need to know the operating principle has largely been taken out. It's mostly about analysis of results that are more important in the context of modern questions in the current syllabus. So what we see about this NMR spectrum is we have an organic liquid P. It has 5 carbon atoms. But we have 3 environments. You can see that there are 3 proton environments, and it is very, very simple environment because this is a singlet, and there are 9 protons. These are called the integrated ratio or the integral. So that means there are 9 protons. You cannot have CH9. There's no such thing. So what you're going to have is CH3 multiplied by 3 because you have a tertiary methyl group there. That tertiary group 3 times methyl there. What we also have is we have 1 hydrogen here. So this is just 1 hydrogen. So it must be CH bonded to something. We just don't know what is the other side of it yet. And this is 2 hydrogen. It's also a singlet. And this singlet is between 3 to 4. This singlet is between 3 to 4 ppm. This is very indicative of alkyl next to electronegative atoms such as oxygen. So most likely we're looking at O and then CH2 bonded to something else. Alkyl next to electronegative atom, whereas this thing which is close to 2, I can't figure out what this one is though. Alright, so let's just think about this. So we must have something electronegative and then CH2 like that. Anyway, so how many protons are present in one molecule of P? So you get 2 plus 1 plus 9, so 9, 10, 12. There are 12 protons. Explain your answer. So integral ratio or integrated ratio, or you can call it integrals, show the number of protons in that environment, show the number of protons in each respective environment, and we are just basically interpreting what the integrated ratio means, number of protons in each respective environment. And we have 3 environments above, and we have just totaled up the number of protons in each particular chemical environment there. So there was 2 plus 1 plus 9 that give us 12 hydrogens altogether, 12 protons altogether. Now when a little D2O is added, you get this absorption disappearing. So very clearly this is a labile proton, and a labile proton in the syllabus include the OH, or it could be NH. So what does this tell you about the group responsible and why? So what we know is that this must be labile proton. So the absorption disappears. Well, actually it must be labile proton. I should probably mention that first. So the group must contain an OH or NH. We still don't know. Okay. So it disappears because due to fast exchange. fast exchange of your labile protons. So labile means easily coming off, and your labile protons are your OH as well as NH. There's your ORNH with D2O. Therefore, we get a swap of these protons become deuterium. So example, ROH plus D2O. I'm going to swap out the OH become OD, and I'll get HOD. So what we can say about this ROD is normal protons. So normal protons on the OD. Therefore, you will lose this absorption, you will lose this signal there. Okay. Now, what does this absorption at 0.9 ppm tell you about the adjacent? Adjacent means the next one on the next carbon. So it is a singlet. It is singlet at 0.9 ppm. So what does singlet mean? Singlet means one line. One line equal to number of neighboring protons plus 1. So if you have one line, therefore we must have 0 neighboring protons. So therefore must have 0 neighboring protons, because the number of neighboring protons plus 1 will tell you how many lines you should get for your splitting. So must have 0 neighboring protons, or you can say 0 protons on the adjacent carbon atom. On the adjacent carbon atom. Okay, so the next one, what group is or are responsible for the absorption at 0.9? Earlier I talked about that it's impossible to have 9 protons on one carbon. This is most likely 3 times the CH3 group. It's sort of like tertiary group there. So this group here is equivalent to this and this by rotational symmetry, because you rotate about the single bond here. So you're going to have CH3 and then 3 of them. So I underline that. So it's just alkyl group next to alkyl group, or you can mention the CH3 3 times like that. And they wanted me to suggest a structure for P. So we know so far we must have that, and we still don't know the formula, do we? We still don't know the formula. So they say liquid P, it has 5 carbon atoms. So C5 H12, C5 H12. There must be oxygen as well, somewhere around there. Alkyl next electronegative atom, C5H12O. Does that make sense? 5 carbon alcohol. I wonder if it could be 5 carbon alcohol. 1, 2, 3, 4, 5. So carbon from 4 bonds, CH3, CH2, 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 OH. I will get 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it looks like it could be alcohol, but we don't know whether it is straight chain alcohol or not. Well, I can tell you it's not a straight chain alcohol. So it is a 5 carbon alcohol. It cannot be straight chain alcohol because of our knowledge that it must be 3 times CH3 there. They give you the singlet CH9 9 proton there, singlet there. And this is the OH. This is the OH. And if there's the OH, we have a CH2 next to oxygen. So we must have, I wonder what must we have actually. 1, 2, 3, 4. So we are left with 1 carbon, a CH2. But then this is CH3. So what I must have must be like this. This is a CH2 next to this OH. So it's C0 neighboring proton. It doesn't couple to this because it's on the oxygen. So this one will be a singlet. So what we're saying is this pink one is one environment, and then now this green one is another environment. So this green one there is 2 protons, so must be this one here. And this pink one there must be the singlet, 3 times CH3 there. And last but not least, you have the OH there, which must be this labile proton, which disappear when you add the OH there. So we can be thinking about this structure. There must be this one, and I'm just gonna draw a better one because this one was the colored version. A structure. So you know you can draw skeletal, or you can draw display. You can draw structural. It's up to you. If you draw structural, straight chain 1, 2, 3. So you know CH3C, draw the branch in a bracket, then you have CH2OH, something like that. What you cannot do is you cannot write the molecular formula like C5H12O. You cannot do that because that is not what they want. They want the structure. Part C, so this is now in AS Chemistry. If you look in AS Chemistry for the 2022 syllabus, you will see these under just right after the carboxylic acid as part of analytical chemistry together with infrared. However, they could still ask you anything from AS in A2, so it could also come out in A2 paper 4, so do not be mistaken, yeah? Your job is to show that there are 5 carbon atoms. The formula you're supposed to use is number of carbon atoms equal to 100 over 1.1 times percentage of, this is going to be M plus 1 divided by the percentage of M. This is the parent ion peak. This is the parent ion plus 1 due to the presence of carbon 13. So 100 over 1.1, my percentage of M plus 1 according to this ratio respectively. M is 9.3, so 9.3 is at the bottom, that's the percentage of M. Percentage of M plus 1 is the second one, so 0.5 on top. So I just need to press my calculator. So 100 divided by 1.1 times 0.5 divided by 9.3, I get 4.89. But of course, these are number of carbon atoms, so you need to give to the nearest whole number. And this is as required. There are 5 carbon atoms altogether, as required by the question. Sure, there are 5 carbon atoms. Next one is also an AS level question now. If you see the AS syllabus for this 2022 year onwards, you are asked on the M, N plus 2, N plus 4. I think in AS, they just expect you up to M and M plus 2. We know that 79 bromine is to 81 bromine is 1:1 isotopic ratio, give or take roughly, because in your periodic table, the relative atomic mass of bromine is roughly 80. So you must have like 50% of each of these isotope. That means when you have M and M plus 2, when you have 1 bromine atom, it's going to be intensity of 1:1. But when you have 3 of them, you can be thinking about your tree diagram that you learned in probability when you did head and tail probability. So we can think about this as 50%, so a half, a half, a half, a half like this. The first one there will give you the M. This 2 will give you M plus 2 plus, and then the last one will give you the M plus 4. Here will be half times a half, which is a quarter. Here you will get 2 combinations, a quarter there plus a quarter, you will get 2 quarter. 2 quarter. And then the last one will be 1 half, a half times a half, you get a quarter. So the ratio of, a quarter is to 2 quarter is to 1 quarter is going to be 1:2:1. This is a fixed case study on the ratio of intensity of these peaks when you have 2 bromine in the molecule. So hopefully that is not something that is too confusing in terms of the mathematics for you. Alright, let me see if I can move this a bit better so that this looks better. Yeah, that looks as best as it could be. Now what is the molecular formula? Molecular formula, the actual number of atoms in one single molecule. We know that there are 5 carbons. We know that there are 2 bromines. We know that actually what else do we know? When an isomer of P, so P was this 5 carbon alcohol, but you want an isomer of P, reacted with corn sulfuric acid. So this is going to be elimination chemistry. So this is elimination of H2O from alcohol. And when you eliminate H2O from alcohol, you will get alkene. You will get double bond. And then this new compound reacts with bromine to form a dibromide. Because alkene plus bromine will give you a dibromide. This is your electrophilic addition mechanism, where the type of reaction is going to be addition of this BR-BR across the carbon-carbon double bond, such that the bromine water get decolorized. So our bromine, our BR-BR must be next to each other in the carbon. So what are we thinking? We started with 5 carbon alcohol. It was C5H12O. So if we have an isomer of P, so C5H12O will still be the formula. You minus H2O, and then you get the alkene. The alkene is going to be C5H10. This is the alkene because you take away the H2O like that. So I can think about that going to alkene and that plus H2O. In the presence of constant sulfuric acid and around 300 degrees Celsius, obviously. Now what happened with this alkene is that you add bromine. You have one carbon-carbon double bond in CnH2 and then you get C5H10 Br2 there. So that is going to be the molecular formula for this compound there. The final product C5H10 Br2. When you have two bromine atoms, they're going to give you 1:2:1 in the M+2, M+4 peaks in the mass spectrum. And that's the end of that 12 mark question there.